Okay, so today we're going to be dealing with triangle relationships. So we're going to talk about triangles, a few things we see with triangles and that we know with triangles and that you'll always know with triangles. So the first thing I want to talk about is how sides of triangles and the angle across from it, they go hand in hand. So I tend to sometimes use the word corresponding on accident, and you might hear me say that, but they're not equal, but they do go hand in hand. So for example, I have this triangle right here, ABC. So triangle ABC. Now notice that angles are usually written in like little letters. So does everybody see how by this little point, this vertex A is angle A, by vertex B is angle B, and by vertex C is angle C. So they'll usually write angles in like little letters, and then like the vertexes as capital letters. Okay, with that being said, now everybody look at angle A here. Okay, look at angle A with me real quick. Noticing angle A opens up on side BC. Does everybody see how angle A opens up on side BC? Okay, so they go hand in hand. They're not equal, but they go hand in hand. This angle and this side go hand in hand. So angle A opens up on side BC. And I even color coordinated it for you to be able to kind of look at it and see. Now look at angle B. Notice how it opens up on side AC. I even start it in red. So they go hand in hand. So side AC. And then once again, angle C here opens up on side. It opens up on side AB or BA. It doesn't really matter how you name it. So AB, and they go hand in hand. So I color coordinate it for you. Okay. So now note, the angles and sides aren't necessarily going to be equal, but they are going to go hand in hand. Your triangles will always make sense. So what I mean by that is, I'll let you finish getting that down. Well, what I mean by that is, the smallest angle, guys, the smallest angle will be across from the smallest side. And the largest angle will be across from the largest side. And the middle angle will be across from the middle side of the triangle. So your triangle will make sense. If it doesn't, then something's wrong. So the important thing with this is to know that angles go hand in hand with the side across from it. That's what I wanted you to get out of this. So if you understand that, that's good enough for your notes. So an angle goes hand in hand with the side across from it. If that's all you understand from this, that's what I really wanted. Okay, so looking at this, let's see if this triangle makes sense. Now remember, like I said, the smallest angle will be across from the smallest side. The middle angle will be across from the middle side. And then the largest angle will be across from the largest side. So let's go ahead and start with our smallest angle. In my triangle, my smallest is 50. Well, let's see, does that make sense? It's across from side 5, is that my smallest side? Does everybody see how that makes sense? Okay, good. Those angles, that angle and that side go hand in hand. And my middle angle is 60. It's across from this side. 8 is my middle side length, right, everybody? And last but not least, largest angle 70 is across from side 9. 9 is the largest side as well. So once again, your triangles will make sense. That's all you need to know. Like you don't necessarily need to write this down. If you understand that, then you're good. Okay. All right. So now the next thing, we're moving on to the next thing of triangles. So the rule is, now this is an interesting rule, and you see it a lot more when you get into some more advanced math, and you see it next year when you start dealing with laws of sines and cosines. But this year you need the basic idea of what makes a triangle truly a triangle. So for a true triangle to be made or formed, the sum of any two sides must be larger than the third side. So once again, the sum, if you add up any two sides, it's got to be greater than the other side. So once again, I'm going to say that again as you get that down. For a true triangle to be made, the sum of any two sides must be larger than the third side. So guys, if this doesn't happen, we get some weird looking triangles that aren't triangles, such as this. See this triangle? That wasn't true. The sum of two sides didn't add up to be the third side. So we have this gap. It can't close off. Well, that's not a triangle. That's not even a shape right here. And then if that's not true, the sum of any two sides must be larger than the third side. You might see something like this, where this side comes and swoops clear down with all this extra hanging. So yeah, it forms a triangle, but not a perfect triangle. You can't form a perfect triangle because if you took that leg and tried to swoop it out here, it would be hanging off in the distance, just like this one. So some weird things start happening if this isn't true. This is what we want. Triangles to be able to fit perfectly. So we're not going to get into too nitty-gritty of that. We get way more advanced with that in secondary 3. And here, that's, if you know that idea, that's good. Okay? All right. So let's see if out of these sides, if side 1, side 2, side 3 of the triangle if this triangle really works here. So if side 1 is length 2, if side 3 is length 3, and side 3, so there's 3 sides of a triangle, is length 6, let's see if we can truly form a triangle. So what you're going to have to do is check to make sure the sum of any two sides is greater than the third side. So I'm going to start out with side 2 and side 3. So that would be 3 plus 6. What is that? What is it? Okay. Is 9 greater than the other side that we didn't add up? Is 9 a greater number than 2? Yes. So that's good. Okay, let's check the sum of some other two sides. Let's do 2 plus 6. 2 plus 6 is 8, right? Is 8 greater than 3? So that one's good. Well, let's check the last one. 2 plus 3, that is 5. Is 5 greater than the third side? No, 5 is less than 6. So guys, this one can't form a triangle. Can't form a triangle with this one. The sum of any two sides must be larger than the other side, the third side. Does that make sense, everybody? Because of this, we can't have a triangle, a true triangle. Any questions on that? So you just got to check it. Okay, another one. Actually, let's see here. Yeah, one more and then I'll let you work for a minute. Oh yeah, and I wasn't able to read your guys' spell quizzes yet either. Yesterday, I just ran out of hours in the day, so I wasn't able to get your stuff graded yet, but I will hopefully tonight, and then I'll rate those spell quizzes. So anyways, don't think I just ignored them, because I didn't. Okay, so last one, before I let you work for a second. So in triangle ABC, now this is just like telling you the triangle name. So in triangle ABC, side AB is 6, side BC is 7, side AC is 10. So we're asked, in a triangle, can a triangle be made, first of all? Which angle is the largest angle? Next question. And then which angle is the smallest angle? So I'm going to assume that a triangle can be made, and then we can check it, just like we were looking at a minute ago. So this is the easiest way to do it, guys. It says in triangle ABC. But if you draw a triangle, and before you start putting on the sides, I would label it. It's way easier to go that way and then label it accordingly. If you start going, okay, AB 6, BC is 7, and then AC is 10, it's hard to figure out where AC and B go. So just go like this first. I have a triangle. I know the vertices are A, B, and C, and then go through and finish labeling it. So AB is 6. So from A to B is 6, from B to C is 7, and from A to C is 10. Well, let's quickly check to make sure that we can truly form this triangle here. 6 plus 7 is what? Okay, 13. Is 13 greater than 10? Okay, we're good. 10 plus 7, 17. Is that greater than 6? Okay, we're good. 6 plus 10 is 16, which is greater than 7. So yeah, we know the sum of any two sides is still greater than the third side, so we can make a triangle out of this. Okay, now it's asking us, which angle is the largest angle? Well, it's going to be across from the largest side, so find the largest side. That is 10, right? So the angle across from that would be angle B, right? So our largest is angle B. Okay, let's look at the smallest. You'll find the smallest side, which is 6. So the angle across from that is angle C. So our smallest is angle C. Any questions on that? Okay, do problems 1 and 2 on the worksheet. I'll leave this up for a second. Do problems 1 and 2 on the worksheet. Ready, go. doing good out there. I'd bring it back to me now because we're gonna learn something else. You can always go back right to those when you get a free second. Don't keep working on them now as we learn something new. Okay? All right, so now we're going to talk about, now we've learned that any two sides of a triangle must be larger than the third side. Now we're going to talk about angles in a triangle. So angles in a triangle, all three of them together, if you were to add them up, it better equal 180 degrees exactly. Exactly. Even 1 degree off or 1 over, not good. You can't do that. So everybody look up here. Look at my triangle. I have angle 1, 2, and 3. If I was to add up angle 1, 2, and 3, it will equal 180 degrees if this is a good triangle, a true triangle. If it's even 1 degree off, we're not okay. So does everybody understand if you sum up that angle plus that angle plus that angle, it better equal 180 degrees? Okay. Awesome. So now we'll go ahead and just apply this in an example. Okay, let's go through and look at these and see if they make sense. So just watch with me to see if these triangles make sense. So we know that all the angles in a triangle must add up to be 180 degrees. So let's check this one. Okay, so this angle's 80, right? This angle's 50 and this angle's 50. Do those three, does 80 plus 50 plus 50 equal 180 degrees? Yes, it does. So this is truly a triangle. Now notice something interesting about this one, just a side fact. If this is 50 degrees, then across from here will be the corresponding side, yeah? This is not the equal side, I guess. I should have said the side that goes hand in hand. And then this is the 50 degrees as well. So across from here better be hand in hand with that 50. So what do you know about those two sides? They're equal. They're going to be equal. If their angles are equal, the sides are going to be equal. Not necessarily to 50, but they'll be equal in measure. Does that make sense? This is called an isosceles triangle. Okay? So just a side note. Okay. Let's see if this triangle over here makes sense. We have 20, 100, and 90. So 20 plus 100 plus 90. How many degrees do we have? 210. 210 degrees. Well, we know triangles must, the measures of the angles must add up to be 180. So this triangle would not make sense. Not true. All right, last one, and then I'm going to once again, last two, and then I'm going to set you free to work for a while. Okay? All right. Does anybody have any questions on that? Okay, let's find question mark, and then let's decide which side's the longest, which side's the shortest on my triangle. So looking at this, we have angles B and C. We need to find angle A. How can we do it?
Add 75 and
Awesome, you're right. Add up 75 and 39 and then subtract it from 180. Or else just do, same thing as exactly as doing this. 180 degrees, all three angles better add up to be 180 degrees. So 180 minus 75 minus 39. And that leaves me with what we have left. So what's my angle? 66 degrees. So this angle must be 66 degrees. Now, once again, all three of those angles will add up to be 180 degrees. So we're good. Okay, what is the largest? What's the largest side? Side AC. How'd you know that?
75 degrees.
Okay, perfect. So 75 degrees you said is the largest angle, and that's across from side AC. So side AC must be the largest side. Any questions? Okay. Shortest side. What's the shortest side?
39.
Is it 39? Good. It's AB because it's across from 39 degrees. It might not be equal to 39. It's across from the smallest angle, though, which is 39. So you're right. AB is the shortest side. Questions on that? So your triangle should make sense. Okay, good. Last one, and then I'm going to set you free to work for quite a while. So here we go. Okay. So looking at this one, we have triangle ABC. We're asked to solve for x, and then what's the largest side. So once again, guys, look at my triangle. Notice I have some variables in here. But just like with all our other problems we've been dealing with lately, If you know a true statement and you have some x's, there's no problem because you'll just set up a true statement and then solve for x. So what would a true statement be? What do we know about the angles of a triangle? They add up to be 180. Very good. Yes, very good, Justin. So a true statement would be to say that angle plus that angle plus that angle equal 180. So I'm going to write that. Write your true statement. That is a true statement. So 70 plus x plus 2, that angle plus that angle plus that angle, so then plus 3x is equal to 180 degrees. There's our true statement. What was that? Thank you. Very good. You're right. So let's combine like terms. You're getting good at this stuff. So we have an x plus 3x, which is 4x. We just combined our x's. And then 70 plus 2 plus 72, which is equal to 180. And then from here, what am I going to do? So you're solving for x piece by piece. So what was your first step? Thank you. Subtract 72 from both sides of the equation. So that gives me 4x on the left. Now, once again, check to make sure those add to be 0 if they better, or you haven't done it right. 180 minus 72. And then what's our next step? Divide both sides by 4. Now, once again, those divide out and become 1. So we have 1 times x, which is x. Okay. So 108 divided by 4 is 27 degrees. Okay, awesome. Okay, we're not finished here. Not finished. Now, we found x, so we took care of the solve for x part. But now we need to know what is the largest side. So to be able to really know the largest side, guys, you're going to have to plug 27 back into x and see what angle B is and what angle C is. So 27 plus 2, 29 degrees. So angle B is 29 degrees, and then 3 times 27, 81 degrees. Okay, so I'm going to circle those real quick. Okay, so now let's go ahead and say, what's our largest side? How'd you know that? So you said AB, AB because it's across from the largest angle, which was 81. So side AB. Good, very good. Does anybody have any questions? Okay. No questions, you're sure? Okay, do problem 3 on the worksheet. Learn. Okay, come back to me again. Here we go. All right, so now let's go through. I don't want you to take notes on this part. Together, we're just going to look at these and see if the diagrams make sense. So now we're going to have to use our logic skills and say, do these diagrams make sense and why not? You've got to explain why not. If you say yes and no on test, you didn't explain to me why. I need to know, because you might have just guessed yes or no right. I want to know you know the math. So let's go through and see if these diagrams make sense, if it's possible or impossible. So take a look with me at this first triangle here. Well, notice the first thing I see is I have a 9 and a 9 on this side, right? So those are equal sides. So what do we know about their angles? They must be equal. So let's draw this correctly so we don't mess it up. This 9 is across from this angle, yeah? And this 9 is across from this angle. And you just said those angles must be equal, which is true. If that's a 9 and that's a 9, those angles must be equal. They don't have to equal 9, but they have to be equal. Are they equal? Not possible. Does that make sense, everybody? Okay, a couple more. Not possible. Very good. Okay, let's look over here. Looking at this one, we have a 3 across from 30 degrees, a 10 across from 100. Do those two at least make sense? Okay, those make sense so far, but we need to know, okay, we don't know that angle, and it's across from 8. We need to know that angle to make sure it makes sense. How could we find that angle right there? They should add up to be 180. All 3 angles better add up to be 180. So 180 minus 100 minus 30 will equal that missing angle. 50, okay? So if that's 50 degrees, does this one make sense? Is that our middle? Is that our middle size angle? Yes. Is that our middle side on our triangle? Yes. So does that make sense? It does make sense. The smallest angle matches up with the smallest side. They're not necessarily equal. Don't let the 3 and 30 fool ya. They go hand in hand, but they're not necessarily equal or anything. And then the 10 and 100, that's the largest side with the largest angle. That's our medium angle with our medium side. So this angle, this one is possible. Any questions? Are you sure? Okay. Couple more. Last one, actually. Is this diagram possible or impossible? We got to be really careful. So let's look at this. Is this diagram possible or impossible? So first of all, I just want to say what we have, and then you can think about it. We have this black parallel line and this black parallel line. So they're parallel. We have our transversal. So now remember, relationship angles, pairs work on the parallel lines, in between the parallel lines. So we're working this way. So we know all of our angle relationships. So I'm going to look at this diagram first. 80 and 80, do those two at least make sense? Yeah, they're vertical angles. These two make sense so far. All right, now they're saying that this is 100 degrees. Does that make sense with what we have? So why do you say no? Are they corresponding? No. They're what? Alternate interior angles. So look, this is alternate to this, and they're both inside the parallel lines, alternate interior. What do we know about alternate interior angles? They must be equal. So this, if we had a true diagram, would have also been 80 degrees. And they gave you 100. So this one would be not possible. And then you would say, not possible due to alternate interior angles. We need to give reasoning. Okay? Does that make sense? Are we all good? Okay, do problems 4 through 8 on the worksheet. But I do need to say one thing. I did notice that, first of all, listen to this really quick. Number A is actually, you have to know the Pythagorean theorem, which you should know. So that's how you have to do that one. You can't, there's nothing about the angles that we know. So with A, you have to know the Pythagorean theorem. If you don't know the Pythagorean theorem, come get help at a different hour or time. Okay? For the Pythagorean theorem is a squared plus b squared is equal to c squared. The only side that matters is the c. That has to be across from the 90-degree angle. The c is the hypotenuse. It has to be across from the 90-degree angle. The a and b don't matter. So you'll have to check to see if this is true. We'll talk more about that too at a later date, but not thinking too hard about it. Sometimes I like to do the hardest math possible instead of just doing the easiest. On A, we know the sum of any two sides of a triangle better add up to be larger than the third side, right? Couldn't you check A that way? Yeah? Okay, so you don't need the Pythagorean theorem for A. So you can all do it. Check all the sum of any two sides better be larger than the third side. Duh. When I saw that right angle, I was like, oh, I'm going to use the Pythagorean theorem, which isn't wrong. I checked it that way. It's just different, harder. Okay? All right, continue. We're shifting gears. This is like, you should have learned this in secondary 1, but it's been a really long time, and it's really hard for most students in secondary 1, but I think today it should be easy for you. Sing it a second time as long as you pay attention closely. So we're going to be learning about, really quick, we're going to do the very basics today. The very basics, we'll get way more in depth later on, in exponential growth and exponential decay. So fancy words, exponential growth means it's getting exponentially larger, it's exponentially increasing. Exponential decay means it's getting exponentially smaller and smaller. So this is what you want to write down right here. Start writing, guys. You need this. Okay? So this is the form of an exponential function. Y is equal to A times B raised to the x power. Now, once again, y is equal to a times b raised to the x power. Couple of things to note and understand, and you have to get it. A is not being raised to the x power. It's a times b. The b is being raised to the x power. Only the b is being raised to the x power. So super important. Okay, so once you know what the function, the form of the function is, you have to know what each thing means. So you have to be able to plug things into the correct place. So A is our initial value, our starting point. The initial value. B is the growth or decay factor. So we're either going to have it increasing, which would be growth, or decreasing, which would be decay. That's our factor. multiplier. That's another word you'll see used today. They will ask you on the worksheet, what's a multiplier? It's talking about the b. So make note of that. And then x is just what you're plugging in, the input, so that would be the time in. So we're going to be plugging in, if it says for 5 years, that's the time we're putting in, so we plug that in for x, the input. So get that down, and then we'll move on to one more thing here. And then okay, so with this, you have to know if you're looking at exponential growth or decay. This is what you already have written. I just screenshotted it and put it back up here. So if your b is greater than 1, so for example, if your b is greater than 1, so 1.25 is greater than 1, right? 2 is greater than 1. 1.001 still greater than 1. If your b is greater than 1, we're talking about exponential growth. That's going to be increasing. So it's going to be worth 100% of its value plus some. Okay? So once again, it's exponential growth if your b value is greater than 1. And then if your b value is less than 1, anything smaller than 1, it's going to be exponential decay. It's going to be decreasing, and it's only going to be worth a portion of the original value. So if we start out something right in the beginning of time, it's worth its full amount, right? And then, for example, if it starts getting worth less and less, that would be decay. It's decreasing in value, and your b will be less than 1. And then you'll know it's only worth a portion of the original value because it's worth less than the original 100% value. So really, guys, this seems super hard, but once I start practicing it with you, it's not a hard idea as long as you know what you're doing and you're thinking about it. So make sure you're asking questions if I'm not clear on something, because it is different, okay? All right, so once you get that down, we'll just start practicing. Because really, it seems way hard right now because that's a lot of words and you don't know what they mean yet. But once we start practicing, you'll say, oh, that makes sense, that makes sense. Here's our first example. Oh, well, let's go through and decide really, really quick if these are exponential growth and decay. I wanted us to see it. So looking at this now, understand the b is the only thing that matters with growth or decay. So if the b is greater than 1, it's growth. If b is less than 1, it's decay. The a doesn't matter for this part. So let's look at this one. Right here, just look with me, don't take notes. Is this growth or decay? Growth because 5 is greater than 1. Looking at this one, growth or decay? Growth because the 3 is greater than 1. So this one's growth. How about this one? Decay because this 1/2 is less than 1. What about this one? Growth or decay? 1.3, is that greater than 1? So it's growth. Okay? All right, how about this one? Careful, 0.01. Decay, that's less than 1. I wrote Judy and I meant D. That one's decay. And what about this one? 0.2. Decay, 0.2 is less than 1. Any questions on growth and decay? Okay, awesome. Okay, first example, I would really suggest watching and just taking, because I can't wait for you to write down the whole thing, and just taking brief notes if you need. Okay, because it's going to make more sense to you if you walk. So it says, the cost of gas has been increasing for the past 10 years at a 25% rate. If gas initially costs $1.35 per gallon, how much does it cost now? So once again, I'm going to read that one more time. The cost of gas has been increasing for the past 100 years and at a 25% rate. If gas is initially $1.35 per gallon, how much does it cost now? So we have to go through and plug it into our formula, but we have to put it in the correct spot. So first of all, notice I put it in red, increasing. So we know that this is going to be exponential growth, right? Increasing means getting larger, so it's exponential growth. Okay, so let's go ahead and plug these things into our function. Now I highlighted it in color so that you could see what we're looking at here. We have to be careful about a few things. Okay, so what we're going to have here is y is equal to a is the initial value. How much did it initially cost? $1.35. I'm not going to write the dollar sign. I'm just going to put 1.35. $1.35. Does everybody see how this is the initial value? It's initially worth $1.35. And then we're going to go ahead and put in our growth or decay factor. Now this is growth factor, so it's worth its full amount, right? 100%. 100% plus what? 25%. So how much is it going to be worth? 125%. Now you can't write 125, guys. You have to write that as a decimal. So how do we write? Good. We write 125% as a decimal as 1.25. Now look at it. Is that greater than 1? So we know it's growth, okay? So we know it's now worth its full amount plus 25% more, so it's 125%. So we have to write it as a decimal though. 1.25 means 125%, and then we have x. Now how long are we talking? How many years? 10 years. So we're going to have 1.35 times 1.25 raised to the time in is 10 years. So this is where you'll get your calculators. Quick. Type it in. You have to type it in correctly. I don't want a fraction necessarily. With this one, I'll accept decimals. So we're doing oops. So we're doing 1.35. Now it's so important you type it in correctly. You have to put this next part in parentheses. So 1.25, close your parentheses. And now here's our caret key. Make sure you don't do times. It's raised. So caret raised to the, and I'm going to put it in parentheses just to make sure, raised to the 10 power. Everybody that okay with that? So I hit enter and I get 12.57. I'm going to round to the nearest hundredths. So 12.57. So gas now costs $12.57 per gallon. So let's hope that that's not the true growth rate. So that wasn't, I mean, that's crazy, right? We haven't ever seen gas that much, but maybe in our future. Okay, so gas is not, we have seen this. This isn't true. Gas hasn't been increasing at a 25% rate, but this is just an example. Okay, well, now let's do another one. Okay, just 2 more examples, and I'll let you work the rest of the time. Here we go. A Pokemon card has been decreasing in value 20% per year. How much is it worth now if it was worth $50 5 years ago? So we got to think about this one. Let's go through and plug things in where we need to. So once again, we know this is our function. First of all, the first thing I look for is what's my initial value? What's it initially worth, the Pokemon card? It was initially worth $50, so I'm going to do 50.00. All right, now let's talk about our growth or decay factor. Well, first of all, you have to decide to yourself, is this growth or decay? Decay, it's decreasing, good. So it's losing value. So guys, in the beginning of time, it was worth 100% of its value. And now we're taking it off. It's decreasing 20% per year. This is super important. You can't put in 20%. That'd be wrong. It's not worth 20% of its value. It's worth not 0.20. It's not worth 20% of its value. It's decreasing in 20%. So you'll do 100 minus 20. How much is it worth? 80% of its value. Does that make sense? In the beginning of time, it was worth 100. It's now decreasing by 20%. So it's worth 80% of its value. So does everybody understand how it's worth 80% of its value? It's decreasing by 20. It started at 100. Minus 20% makes it worth 80%. Does everybody get that? So this is 0.80. You have to write it as a decimal. And then raised to the x power, and it's 5 years. Okay, so it says how much was it worth? How much is it worth now if 5 years ago it was worth that? So once again, it's been 5 years. Let's see how much it's worth now. So 5, because that is x. Do you have questions on how come I'm using 80% instead of 20? Okay. Type that in for me in your calculators, and what do you get? 16. Yep, you're right. 16.38 will round to the nearest hundred. So it was 5 years ago. This Pokemon card was only worth $16.38. Oh no, wait. Yeah. No. How much is it worth now? So 50 years ago, it was worth 50 years ago. 5 years ago, it was worth $50. So you know when Pokemon cards were popular, you had a cool Pokemon card. It was worth $50. Now when you get on eBay to sell it, it's only worth $16.38. Does that make sense? Okay, awesome. Last one, because this one's tricky. The wording kind of gets tricky on this next one because we have to think about it a little bit. All right. Okay. So a new apartment in New York is decreasing in value each year at a 10% rate. If someone paid $500,000 2 years ago, how much is it worth today? And then how much will it be worth in 2 years from now? So first of all, this is exponential decay, right? Okay, let's just go through and plug in what we know. So y is equal to, what's our initial value?
500,000.
Good, 500,000. Very good. And then what's our rate? What's the, what is it worth? What is it worth? 0.9. It's worth 90% of its value, yes. Thank you. So it's worth 90%. It's decreasing by 10%. It originally was worth 100%. It's decreasing by 10%. So it's worth 90% of its original value. So it's not decreasing too much. So it's worth 90%. Now look at it, guys. We know it's decay because that's less than 1, right? So we've done this correctly. And it says, if someone paid $50,000 2 years ago, how much is it worth today? So now, guys, we've got to think about this. This was 2 years ago, it was worth this. How much is it worth today? Now you can't do, okay, this is where it gets kind of confusing for some people. So since we're talking 2 years ago, that's before time, right? That's like 2 years ago. Previous, back in time. I'm talking back in time, right? So we've got to do a negative. So we're doing -2. Because we want to know back in time, what was it worth? Does that make sense? Back in time, what was it worth? So now I put in -2 because this time we're going back in time. Okay, so now type that in and what do you get? 283.95. Okay, good. So you guys, 2 years ago, this apartment was worth $617,283.95. It's now only worth $500,000. Does that make sense? Now when it says, how much will it be worth in 2 years from now? That's in the future, right? So we need to do +2. So we're going to plug it in again. 500 times 0.90, and in 2 years from now, 405,000. That's it. Yeah, $405,000. So now, guys, 2 years from now, when you sell it, you're only going to get $405,000 for it. Does that make sense? So if you're going back in time, now you have to be careful when you're thinking about these, because you just gotta be careful. Okay, so if you're going back in time and you want to know what it was worth back in time, you'll do negatives. And if you want to go forward, like how much is it worth in a few years, you'll do positive exponents. Any questions on that? Okay, finish up the worksheet. Oh, but we do need to fix one. So go to number 6 really quick. We can't do that one without knowing how to undo things that are in the, okay. We just can't do that one with the knowledge we have right now. That's a pretty advanced problem because of what it's asking you to do. You have to know inverses and stuff, and you know. So I'm going to change the problem. So read it with me. It says, at the band's peak of popularity, a signed black diamond poster sold for $500. 3 years later, the band was almost forgotten, and the poster was worth only $10. So I'm going to just say the poster was worth 10% of its value. So write that out. Because if you write the $10 thing, that's going to be, you're not going to be able to do the problem. So once again, the poster was worth 10% of its value, not worth $10. That problem would be totally different. So it's worth 10% of its value. So from there, now you can finish up that problem. Okay? So not worth $10, you'd have to go through and find that. It would just be way hard. We don't know how to do that yet. So it is worth 10% of its value. Now you know how to do it. Does everybody understand the change? Okay, now finish up the worksheet. I want your working till the bell rings, please. Ready, set, go.